Hi, let's get started with our section, and in this video I will introduce to you the basic techniques of machine learning. So in this section we will cover the fundamental techniques of machine learning. We will use these throughout the course to solve interesting cybersecurity problems. We will cover both fundamental foundational algorithms such as clustering and gradient boosting trees and solutions to common data challenges such as imbalanced data and false positive constraints. A machine learning practitioner in cybersecurity is in a unique and exciting position to leverage enormous amounts of data and create solutions in a constantly evolving landscape. And that is all in this video, so I hope you enjoy it, and I will see you in the next video. Hi, let's continue with our section. This video, I want to talk about trend test splitting the data. So in machine learning, our goal is to create a program that is able to perform tasks it has never been explicitly taught to perform. So the way we do that is to use data that we have collected to train or fit a mathematical or statistical model. The data used to fit the model is referred to as training data. The resulting trained model is then used to predict future previously unseen data. So in this way, the program is able to manage new solutions without human intervention. So let's write some text for that. So in machine learning, our goal is to create a program that is able to perform tasks it has never been explicitly taught to perform. So the way we do is to use data we have collected to train or fit a mathematical or statistical model. So the data used to fit the model is called training data. So the result of trained model is used to predict the future. Previously unseen data. So in this way, the program is able to manage new situations without human intervention. So one of the challenges for a machine learning practitioner is the danger of overfitting. So challenge is overfitting. So which is creating a model that performs well on training data but is not able to generalize to new. So which is a model that perform well on the training data, but is not able to generalize to new previously unseen data. So in order to combat the problem of overfitting, machine learning practitioners set aside a portion of the data called test data, use it to only to access the performance of the trained model. So to solve this problem, machine learning engineers set aside a portion of the data called test data and use it to access the performance of the trained model. As opposed to including it as part of the training dataset. So this carefully setting aside of testing set is key to training classifiers in cybersecurity, where overfitting is an omnipresent danger. So overfitting in cyber security is an omnipresent danger. So one small oversight, such as using only beginning data from one locales, can lead to the poor classifier. So one small oversight, such as using only beginning data from one locale, can lead to a poor classifier. So there are various ways to validate model performance, such as cross validation. So for simplicity, we will focus mainly on train test splitting. So there are various other ways to validate model performance, such as cross validation. For simplicity, we will focus mainly on train test splitting. So, and that is all in this video. I hope you enjoy it, and we will implement it in the next video, and I will see you in the next video. Hi, let's continue with our session. In this video, we will implement the train test split. So first, we need to import the train test split module. So the first step is we need to mount the drive, and because I did upload the dataset into the Google Colab, so we need to mount the drive in order to get access to the Google Colab, and then we just need to Colab notebooks. So they will give you a link, to get the API, and then you just put in. So let's run the cell. Because I already have, so I already mounted the drive, so that's why I don't have any API. So if you mount the drive, and then they will give you the link, and you just click the link, and then you just get access to the Colab notebooks, to the allow the access to your Google Colab, Google Drive, and then you just copy the link and then paste in here, and then you just press enter, and then it will mount the drive for you, and then you just cd the content to the Colab notebooks. So I upload the data inside the Colab notebook, so it's very easy for me. So you don't have to install everything. So the first step is we need to import train test split module and the pandas library and read features into X and label into Y. So now we will have the from sklearn dot model underscore selection. We'll import the train underscore test underscore split. So now we need to import pandas as td. So let's run. So why does it take so long to import the library? So it's already done. And now we will have a df equal pd dot read underscore csv. And now we'll have is the data our code is not underscore underscore missile underscore test underscore database dot csv. So let's run the cell. So if you upload it, it's already inside at pd not pf. So that's why I have the error. And now we get rid of the error. And now we have y equal df missile name, and then we have x equal pd dot drop. So we'll have is missile name comma axis equal 1. So next we need to randomly split the data set and its label into the training set consisting of 80% of the size of the original data set and a testing set 20% of the size. So first let's run the cell. Axis equal to 1. So it should be here. And now I just change because it should be I think I miss. So x equal df dot drop pd. No, pd, this should be df. So the data frame. y equal x small x df dot drop. So it should be exactly the same name, and we get rid of all the error. And now we will randomly split the data set and its label into a training set consisting 80% of the size of the original data set and testing 20% of the size. So now we have x underscore train, comma x underscore test, comma y underscore train, comma y underscore test equal train underscore test underscore split. And now we have x comma y comma test underscore size is equal 0.2, and then we got random underscore state equal 31. So we will apply the train test split method once more to obtain a validation set, which is the x val and y val. So let's run the cell, and now we will apply the train underscore test underscore split method once more to obtain a validation set, which is x underscore val and y underscore val. So we got x underscore train comma x underscore val comma y underscore train comma y underscore val equal train underscore test underscore split. So we have x underscore train comma y underscore train comma test underscore size is equal 0.25 comma random underscore state equal 31. So we will end up with a training set that is 60% of the size of the original data, and the validation set is 20%, and the testing set is 20%. So I got the error again, and this should be random. So we will get will be 60% of the size of the original data validation set of 20% and testing set of 20%. So we will bring the length of x underscore train one, two, three, four. So x underscore train, y underscore train, x underscore val, and then y underscore val, x underscore test, and y underscore test. So let's bring to check 81, 81, 27, 27, 27, and 27. So that is really good. And how does it work? So we start by reading in our data set consisting of historical and continuing missile experiment in North America. So we aim to predict the type of missiles based on the remaining features such as facility and time of launch. So let's do it. So how does it work? So first is we start by reading our data set consisting of historical and continuing missile experiments in North Korea. I mean Korea. So we aim to predict the type of missile based on remaining feature. So such as facility and time of launch. So this concludes the step 1, and in step 2, so this will be our step 1. And now in step 2, we apply the sklearn train test split method to subdivide x and y into a training set. So we have a x underscore train and y underscore train. And also a testing set which is the x test and y test. So the test size is around 0.3 parameter. So parameter, so means that the testing set consists of 20% of the original data, while the remainder is placed in the training set, and the random state parameter allows us to reproduce the same randomly generated split. So now let's talk about step 3. So step 3 is important to note that in applications, we often compare several different models. So the danger of using the testing set is to select the best model. Is that we may end up overfitting the testing set. So this is similar to the statistical side of the data fishing. So in order to combat this danger, we need to create additional data set called the validation set. So let's write some note for that. So in step 3 that we often compare several different model, and then the danger of using the testing set is to select the best model, is that we may end up overfitting the testing set. So this is similar to the statistical side of data fishing. So in order to solve this problem, we need to create an additional data set called validation. Additional data set called validation data set. So it's called validation set. So in step 3, we choose our parameters so that, mathematical speaking, the end result consists of a training set of 60% of the original data set, a validation set of 20%, and a testing set is 20%. And finally, we double check our assumption by employing the len function to compute the len arrays. So now let's write step 4, so the final step. So step 4 will be double check our assumptions by employing the len function to compute the len of the array. So, and that is all in this video. So I hope you enjoy it and you can use this step to perform any machine learning, deep learning, or artificial intelligence problems. And I will see you in the next video. Hi, let's continue with our section. In this video, we will standardize our data. So now for many machine learning algorithms, performance is highly sensitive to the relative scales of features. For that reason, it is often important to standardize your features. So to standardize a feature means to shift all of its value so that their mean equals 0, and to scale them so that their variance is equal 1. So let's write some text for that. I will add text, and in here, to standardize a feature means to shift all of its values so that their mean equals 0, and to scale them so that their variance is equal 1. So one instance when normalizing is useful is when featuring the PE header of a file. So the PE header contains extremely large values. For example, the size of the initialized data field and also very small ones. For example, the number of sections for certain machine learning models, such as neural networks. The last discrepancies in magnitude between features can reduce the performance. So now let's start to standardize our data. So I have a mouse in here, so I just run the cell. So this one is you have seen from the previous video. So this one is just a mouse the drive. So it will give you the URL link and then you go here and then you log in and then you allow and then you just copy it to here and then it will mount the drive and then you just cd the content to the Google Colab. So I missed the S, so that's why it cannot cd the drive to the Colab notebooks, and now it's is. So now we will start by importing the required library and gathering a data set. So we start by importing the required library and gathering a data set. So first we'll import pandas as pd data equal pd dot read underscore csv, and then we'll have is 5 underscore pe underscore header dot scv, and then we have a set equal comma, and then we need to drop. So we have x equal data dot drop open brackets close brackets, and then we got the name and then comma malware, and then we have is access is equal to 1 and then dot to underscore numpy. So now let's run the cell to see what is happening. So I got the name error 5 underscore pe underscore header dot csv, and then we did successfully import the library and gathering a data set. So now next we'll standardize x. So next is standardize x using standard scalar instance. So now we will from sklearn dot pre-processing we will import standard scalar, and we got x underscore standardize equal standardize so standard scalar dot fit underscore transform x So now let's print x underscore standardized. So this is how it looks in the standardized our data. So how does it work behind? So we begin by reading our data set. So this one, which consists of the PE header information for a collection of a PE file. So this vary greatly, with some columns reaching hundreds of thousands of files and others staying in the single digits. Consequently, certain models, such as neural networks, will perform poorly on such unstandardized data. And then in step 2, here we instantiate the standard scalar and then apply it to rescale x. So we will rescale the x by using the fit transform x. So as a result, we obtain a rescale data set whose column corresponding to features have a mean of 0 and a variance of 1. So it is really important to standardize your features because performance is highly sensitive to the relative scale of features. So let's write some text for that. So it is important to standardize features because performance is highly sensitive to the relative scale of features. So, and that is all in this video. So I hope you can successfully standardize your data successfully, and I will see you in the next video.